Welcome back, guys. Today we're going to be solving the recent paper of February-March 2025. Let's just begin. Get my pen. So, the first question is about the equation of a curve. It's given, an equation of a line is given, and we have to prove that the line and the curve do not meet. And we have to find the values of k here. So, to find the values, look, this is y as well, and so is this y. Both are y's, so that means they're both equal. Substituting them equally, we are trying to solve this equation. So now we know that if the lines and curves do not meet, the discriminant b squared minus 4ac should be lesser than 0. And if I have this equation here, this is my a, this whole thing is my b, and this my constant is c. So keeping that in mind, we will solve b squared minus 4ac for lesser than 0, open the brackets, solve it, and then we get an equation for k. We factorize it by splitting it into middle terms, and then we make the factors. Now we have the value of k as minus 1, minus 5, and positive 11. Now we just have to decide what would be the sign, greater than, lesser than, equal to, what are the signs? So if we go up, before we were factorizing, like at this point, we see that the value here, we usually call this value a. Okay, the value with the variable square is usually called a. And if our a is greater than 0, our function is said to be a minimum function such that it has a smiley face like this. And if our a is lesser than 0, then our function is maximum and we have a sad face. So if we see this function is a smiley face, meaning that we would have a somewhat like this diagram. You could always make this diagram. It's more easy to understand your questions and knowing what you are required to do. So I draw a number line, plot it, minus 5 would be here, 11 would be here. And since our equation here stated that our value of k squared minus 6k minus 55 should be lesser than 0. So if my value of this curve, if I see this curve, if my values are lesser than 11 and greater than minus 5, all my values would be lesser than 0 because, look, this is the number line. These values would be lesser than 0. That's the reason our value of k would be lesser than 11 and greater than minus 5. Moving on to the next question. We have a graph, okay? A diagram shows a curve and the opposite, okay? So first of all, we have to find the gradient at exactly this point P. So everyone knows what's a gradient. A gradient is also called the derivative. dy over dx, first derivative, is also known as a gradient. So it's quite simple now, meaning that dy over dx can be easily found because we're given the equation of the curve. Now we differentiate the equation of the curve. Now when our p is 0, it's given that our x is 1. It's given in the equation. It's given in the question, okay? So when our x is 1, we find the gradient is 9. Now they're asking us to find the coordinates of m. And it is stated in the question that m is a minimum point. And a minimum point, there's a condition that our derivative at the minimum point is 0. So we solve it. Okay, the derivative. How did we find the derivative? So derivative of 2x squared minus 5x raised to power minus 1 plus 3. So for the derivative, we multiply the power. We multiply the power with the outside number and we subtract the power with 1. So 2x squared. We take 2 outside, we get 4. And then 2 minus 1 is 1, so x has a power of 1. Minus 1 multiplied by minus 5, positive 5. Minus 1 minus 1, minus 2 is the power. So we're plus 3 here. Well, x is 0, the power for x. And 0 multiplied by 3 is 0. So in other words, you can just remember that the derivative of a constant is always 0. Now taking this derivative, solving it, we get x cubed is equal to minus 5 over 4. X is equal to minus 1.08 because it's written clearly 3 significant terms. There's a difference between 3 significant terms and 3 decimal places, so please read the questions properly. Then we need to find y. Now, I've seen many students making mistakes here at this point when you're supposed to find y. They put this value of x in the derivative again, and I don't know what they do. They try to get the value of y from here, which is totally wrong. Because to find y is an output that we get after we put something into the original function, which is this, guys. This function is here. This function is the original function. So whatever we get value of x we get is minus 1.08. We substitute it right in here to get the value of y. That cleared, we solve it, we get the minimum point as minus 1.08 and 9.96. Now, question number 3 is quite an easy question from series and expansions. In this, they're asking us to do the complete expansion, okay? A little different question than usual. We usually are supposed to find the independent terms or specific x cubed terms. And February and March papers are usually small, which is very good. So now solving this paper, we get 2x minus 3 over x raised to the power 4. So it would be very, very difficult if we tried to solve the powers. So we have expansions, binomial expansion and theorem. We use them. So taking that, we know that if I have a term, like this is my power 4, term A, term B. So first things first, add here, combination. What is this? This is combination. Actually, if on your calculator, this function c, that is called c. It is usually with the division sign, and you press shift with it. Use that to find this combination. 4c0 into 2x raised to the power 0 minus 3x. Okay, if you note the powers here, whenever I have a power, all of them sum up to 4, which is the greatest power and the given power here. 3 plus 1, 4, 2 plus 2, 4, 3 plus all of these powers should be equal to 4. And if they're not 4, you are making a mistake and you have to just check where it is wrong. Now, if I try to solve this, it's all given. The steps are totally written out here for you. If you don't understand, let me know. I will help you. Now, 4c0 and all these, now simplified, all the calculator work. No need to do the calculation by yourself. We get the final equation as highlighted here. Now, the next question is a little good one. They're asking us to determine the coefficient of x squared in an expansion in which x squared plus 5 is multiplied with our previous expansion. Now, if I see this expansion here, and we're supposed to multiply with this, and we're supposed to find the coefficient of x squared, that means that all the terms that I get after multiplying should be in the power of x squared and the others can be ignored. So what would I multiply x squared with to get an answer that's already an x squared? This thing? No. It will give x to the power 6. This thing? Also no. So no, no, and yes. Because if I multiply 216 with x squared, I will still get an x squared term. So we get one value out of the way. What is the next value? So what would you multiply with 5 to get an x squared? No. Yes. Why no? Because it will give us a power of x4, guys. So this one is the one that we're looking for. Now we multiply them, put 3 dots, meaning that this expansion is continued. These are not the only 3 values in this expansion. Now we solve it, and we write at the end, the coefficient of x squared is minus 264. Done with another question, move forward to question number 4. So this question is from chapter number 4 of our book, and most of the students, when these type of questions come from chapter number 4, they get confused on what they're supposed to find. So now let me help you in understanding these questions easily. Let's take a blue highlighter. Okay, so you can also do with a pencil on the paper when you're doing it. So let's highlight the things we know. OA on B is 10 centimeter. This is a given, and this is the arc. And this is 6 centimeter radius for what? And okay, now this is the highlighted information that I have. Now we are supposed to find the perimeter of the shaded region. And the shaded region, as we can all see, let me change the color of the pen so it doesn't mix up, is this shaded area. Now, what do we need to find the area of the shaded region? We have this side already. We have this side already. We can find the arc length very easily by using the formula. The problem only here is the length of AB. And now we're supposed to find it. Well, you see, it's a triangle. And triangle, we could use this SOHCAHTOA, which means sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite and adjacent. Simple. Just a trick. If you have your own, like some people have curly brown hairs one, you could use that as well. It's totally up to you. So now at the first line, I'm writing what are the things that are required for the parameter. Like I need AB, this side. I need AC. I need DB, and I need the arc CD. Now, to find the length of AB, we can't find the length of AB directly, but we can do it by dividing into two triangles. If I divide it into two triangles, I'll get a triangle of something like this. It's a rough drawing, don't mind it, okay? So let's say this is my 0.4 then, because we are going to divide it into parts. So our angle is going to be now 0.4 radians, okay? So if this is my angle, my hypotenuse is 10 centimeter already. So that means I can easily find this side because it would be equal to this side. So now let's see. Sine, opposite over hypotenuse. Simple. We're going to use sine theta. Sine 0.4 would be equal to my opposite, meaning half of the AB, into 10. And that's exactly what I wrote here. You can easily see the explanation. Now we can move forward. So now we are easily finding the value of AB. We can easily calculate the parameter by doing all the steps, and we are done with finding the parameter. Now we need the area of the shaded region. Again, a very easy question. To find the area of the shaded region, what do we need? Well, we need to find the area of the whole triangle and then subtract the area of the sector, because you can see this by visualizing this image in your mind and trying to understand what do you need and what do you not need. So taking that in mind, we are going to minus the area of the sector from the area of the triangle. Now the thing is, we need to find the area of the triangle. For the area of the triangle, we need 1/2, a base, and into a height. And there's another formula, 1/2 sine C into AB. Okay, so this one is very easy to use. We could easily use this formula right now. So, but I'm going to go with the above one, base into height, because it's more common among us students. So taking that in mind, what is a base? We did not have the base. So we could just divide 7.79 by 2 to get our base. 7.79 divided by 2 would be our base. And 1/2. And we're going to multiply by 2 because we have two triangles. Now we're left with finding the height. To find the height now, adjacent over hypotenuse would be the formula here. So cos 0.4 into 10 would be the answer. And simplifying it, let me just calculate this part. I think we do get the answer that we're looking for, 7.79 divided by 5 into cos 0.4. Base into height. Oh, I made a mistake. 2 and then multiply by 10. 35.8. Yes, 35.9. We get it right. We get it right. We could also use this, and if I do it with the other one, we'll still get the same answer. There are two formulas, 1/2 base into height. And we could also use 1/2 AB sine C. Like this side, and the angle between them. So now we have found the area of the triangle. We just need to find the area of the sector with the formula 1/2 r squared theta. Simple, and we have found the area as 21.5 centimeters square. There was no restriction in about significant figures in decimal places. It's totally up to you how you give them. But it's better to sometimes round off your answer to the nearest 1 decimal or 2 decimal places. Question number 5, arithmetic progression. The first term is 5, common difference is 6. Find the sum of all the terms that lie between 150 and 400. A tricky question because we don't know when does 150 and 400 comes. Tricky question, let's try to solve it now. So, they're saying that there's a term that is between 150. Like if I draw a number line here, 150, let's write a number line. This is my 150, this is my 400. Like all the numbers that are here in this part, we are supposed to find the sum of them. And the thing is that we can't go smaller than 150. So our number should be greater than 150, whatever the number is, and it should be lesser than 400. Like so. Whatever my number is, we know that the term an, we're trying to find the term and the value of n as well. So an, this is the formula to find any term in an arithmetic progression when we're given the first term and the value of d. So the first term was 5. Our value of d is 6. We try to find the value of n at which place our first value is supposed to occur. So if I do all these calculations, I get 25.2. I round it up to 26. Now, why am I doing it to 26? Why not 25? Next question, a very beautiful question. Like if I put the value of 25 in this equation, I would get the value of my term as, wait a minute, let me just do it. 6 as 149. If I put 25 as my n is 25, if I put this, I'll get 149, which is lesser than 150. And we're supposed to find the sums of numbers that lie between 150 and 400. So we're gonna round it up to 26. And if I do it 26, then I'll get 155, which is exactly between the terms. Similarly, we're going to do with lesser than 400, and now we get 66.8. Now, what are we supposed to do? Round up or round down? I'm doing round down. Now, why? Similarly, put the values 66 and 67 in this part. And if you get the answer that is satisfying this equation, choose that value. Because if I put 66 in here, I'll get 395. But if I put 67 only, I'll get 401, which is again exceeding my limit. So I get 155 and 395. Now there are two ways. Now we are supposed to find how many terms are in between them. Well, 26 and 66. If we do directly with the calculator, subtracting them, we'll get 40. But that is totally wrong because we are not considering the first term. That's why we're going to write 41. Like if I have a number line, let's say count the numbers between 1 till 3. 1 to 3. Would you say that there are 3 minus 1, 2 numbers? No, there are actually between 1 and 3, there are 3 numbers. Because 1, 2, and 3. You can't do 3 minus 1 to find how many numbers are there between a given range. So if you do that, you have to add 1 to get the correct answer. That's why 40 plus 1, we get 41 terms. So S, sum of 41 terms, and then n over 2 into a1 plus an. Now this is another formula to find the sum. There are actually two formulas to find the sum of an arithmetic equation. They are as follow. Let me write them for you. 2a1 plus n minus 1 into d. This is one formula. And this is like this formula is expansion of this already given formula. So if you do this, you'll get the answer, which is totally correct. Now moving on to the next question. This paper is quite easy, by the way, to solve. Now this question is good. Now in question number 6, we are given a diagram. Okay, the diagram says that this is the circle, xy radius are greater than the least distance. Now this is the tricky part. Read it twice. The least distance between any point on my center C and the x-axis is 8 units. This is my center C. This is my x-axis. Any distance between here and here is 8 units. And the least distance between any point on the C and the y-axis is 5 units. And that means from here to here is 5 units. Now we're supposed to find the coordinates of the circle. I know I am also in the most of the people because the first time I did this question, I wrote the circle's center as this, which is wrong. I later found out. And the reason it was wrong, let me explain you because I also had to think about it a little bit. So you see, if there's a point, let's say this point. Let's say this point here is my y, x and y. Okay, so if I'm supposed to find in terms of r, okay, I'm sorry. Then if I'm supposed to find in terms of r, the diagram shows least between any point on C. Any point, oh, not the center. Okay, I was supposed to read this question correct. Okay, they're saying no, not between the center and the y-axis, any point here and here. Okay, now getting that in mind, we're supposed to find the center. So if I say this is r, so this is 5 plus r, this distance would be 8 plus r. But now we're supposed to find which axis is which axis. So if we see this axis is horizontal axis is my y-axis, so horizontal axis is my x-axis, vertical axis is my y-axis. That's why it's r plus 5 and r plus 8. Now, given that the distance between the origin and the center of the circle is 15 units, find the value of r. Now what are they telling us? They're telling us that there's a distance between the point of origin, meaning 0, 0, and this point r, which is the center. And what is the value of the center? This is the value of the center. Now 15 units should be equal to the distance between r plus 5, r plus 8. Why are we not subtracting 0? Because we're just skipping steps. There's a subtraction here because the actual formula for distance is this one. This is the actual formula, but subtraction of 0 is totally nullified because it has no value. So solving it, opening the squares, cutting the everything, we get a final equation as r squared plus 13r minus 68, splitting middle term, making factors. Now we get two values. R minus 4 is equal to 0. That means that my r is 4. And r plus 17 is equal to 0, meaning my radius is negative 17. But wait a minute. Do we measure the length in negative? No, we don't. That's why negative 17 is totally ignored. So our radius is 4 units. Next question. A point on a circle that is furthest from the region is denoted by P. Find the gradient of the tangent of the circle at P. Lovely question. Now guys, we're supposed to find the gradient at this point. But to be very precise, it's this point here that I'm covering. But because if I try to draw a line from the origin to the radius to point P, it would be an exactly straight line. And if there's a straight line, the gradient at any point is same. That means that if I find the gradient between the radius and the origin, it would be the same as finding the gradient between point P and the origin. So let's find the gradient between the origin and the radius, which is 12 over 9. Now we have to find the gradient of the tangent. Now, if a tangent is drawn, it's going to be perpendicular to our original line. And perpendicular, there's law. If the lines are perpendicular, their gradients are the negative reciprocal of each other. Using that formula, minus 9 over 12, changing it, and then we're going to simplify it. We get the gradient of the tangent as minus 3 over 4. Next question. Okay, these are the good questions now. Trigonometry, very easy questions. You just need to learn a few formulas, and the most common one is the given formula cos square theta plus sine square theta. Memorize it. This is the most common formula you need to remember. Now we have two sides. Left side, right side. Now you have to choose which side you're supposed to do first. Quite confusing. Well, I am going with the left side here because I think it would be easier for me to expand tan square into sine square instead of changing sine square into tan square. So expanding it. And guys, in exam, if you don't understand which side you want to go with, choose any side and do it with a pencil, okay? And then if it doesn't work, do it with the other side. This is like a hit or trial method. You can choose any method you want. So 3 tan square theta plus 5 sine square theta. Changing tan to sine and cos because we have a formula for tan theta as well. Tan theta is equal to sine theta over cos theta. This is also a very common formula that are used to prove identities. These two are very common. Remember them. Now, we are going to change cos square theta into our sine because our answer on the right-hand side is all in functions of sine. So changing cos square theta is into minus 1 sine square theta. Multiplying, taking denominator common and LCM whatever. And then we get a final equation here. Then we simplify the common terms, this and 3 sine squared theta plus 5 sine 8 sine theta and minus 5 sine raised to power 4 theta. And our denominator is 1 minus sine squared theta. Yes. Hence, it is proved that left side is equal to right hand. Now we are given an equation to solve. What are we supposed to do? Well, we just proved this same identity right now in part A. Take it and substitute it. Simple. Now we have all the values in sine squared theta and sine raised to power 4 theta, like all are in sine. We can work with the function of sine. Now we're going to simplify it and try to get a simple equation. Now we're getting the powers in 4s and 2s, and it's going to be difficult for us to solve in 4s and powers of 4s and 2. So we can just let sine squared theta be a variable for a minute. You could choose x, you could choose any variable you want. I'm going with y. So 5y squared minus 17y plus 9 is equal to 0. Now we're going to use the quadratic equation because you see there are no common, you can't go with split the middle term method because there's no common factor that would give us minus 17. So we're just going to go with the quadratic equation and we get sine squared theta is plus 17 plus minus square root of 109 over 10. Now, we have one side, we have two sides. Now, if I do the sine squared theta is equal to 2.74, we need to take the square root. And when we take the square root, we get the answer in plus and minus both. And now we get in plus and minus 1.66. Plus or minus both are not possible because the values of sine theta for any given angle should be between positive 1 and negative 1. And this is exceeding the limit, hence it is not possible and it's ignored. Now going to the other side, trying to solve it, we get sine squared theta is equal to 0.66. Now taking the square root, we get plus minus 0.81. Now, our theta, we're going to ignore the negative sign for now, and we're going to just find the value of theta in degrees because, well, the range was given in degrees, that's the reason. So theta is equal to 54.1 degrees. Now, to find the angles in other quadrants, we are going to use the plane, x and y plane, quadrant 1, 2, 3, and 4. So when is cos sign negative and positive? So add sugar to coffee. So it's positive in quadrant 1 and 2. Quadrant 1, we get 54.1. In quadrant 2, it's 180 degrees minus 54.1. These are the formulas you're supposed to remember. But I can't do anything to help you in this part, okay? You have to just remember these things as well. And it is negative in quadrant 3 and 4. But in quadrant 4, it exceeds the limit of 270. Hence, we're just going to take quadrant 3, 180 plus the angle that was given 54.1. We get our three answers. So theta is equal to 54.1, 125.9. We are rounding off the angles to 1 degree. That's fine. That's fine. Question number 8. Almost at the end of this paper. Geometric progression in such okay. We're given the second term. We are given the sum of infinity. We are supposed to find the common ratio. Now, it's a geometric sequence. To find any term in a geometric sequence, we know that any term, a raised to power r raised to power n minus 1. This is the formula to find any term. So we are finding we have the second term. That means a2 is equal to ar. Then minus 120 is equal to ar. So s infinity is equal to a divided by 1 minus r. This is the formula. Taking 1 minus r to the other side and putting the s infinity value as 160, we just get a. And we know that from this beautiful equation that we have here, we could derive the value of a as minus 120 over r. Very simple math, guys. And then we put this value right over here, and then we get all the values in r, and we're easily going to be able to solve it. But the problem is, there's no problem. Multiplying all the sides with r, we get minus 60r squared, and then we divide them with 4 to get it up. No, are we not dividing with 4? Let's see, wait a minute. Yeah, we're dividing by 40 here. At this step, we're doing a division by 40 to simplify it as much as possible. And after the simplification is done, we get a simple equation. Splitting middle term method, most common and easiest method. Or we could just use our calculators to solve this equation, but they usually ask for steps. And we get two values now. Now, guys, we get two values of r after all the simplification. R is equal to minus 1 over 2, and r is equal to 3 over 2, which means 1.5. Well, for the sum of the infinity to exist in the first place, our value of r should be lesser than 1, meaning that our series should be convergent. Now, it's a fancy word to say convergent series. Well, actually, if I have a number line, and my series keeps on going and going and going, well, a convergent series is such that it comes to an end at a certain point. That means it's possible for us to find the sum of infinity. But if my value of r is greater than 1, then my series is divergent, meaning that there's no possible way that my values would come to a specific end. That would be nearly impossible for us to find the sum of infinity for a series that is divergent. So for a sum of infinity to exist, our r should be lesser than 1. This is a rule. It's in our book, I think at page number 182. I don't have the book right now. No, I have the book right now. Give me a minute. Let me share our book here. So this is our book. So guys, if you see at page number 182, this is the online book. So it's possible it won't match with our physical book, but the condition for an infinite series to converge is given. R should be lesser than 1 and greater than minus 1. And for an infinite series to converge, then we can find the sum of infinity. That's why our value of r of 1.5 was ignored. Okay, so let me share the other screen now. And let's get back to work. So that's why we are going to ignore this value of r of 1.5 and just going to consider minus 0.5. Now, the first 9 terms of the progression are now removed, taken away. They're gone. Now, find the sum of infinity for the remaining terms of the progression. Now, there's a way that I have used to solve this. Like, we could find the first term. We could change the first term by removing the first 9 terms. Let's find this next term that's going to start the series now. Like if my series was starting from 1, 2, 3, 4, 5, 6, 7, 9, this is my 10th term, and then we're going forward. We are going to remove all these terms. They are neglectable. We're going to start from here. So let's take this as my first term. Now we're going to try to find this a by simple. A n is equal to a r raised to the power n minus 1. Because we have the value of a, we have the value of r now, we could easily find the a value of a10. Now having the value of a10, we can easily find the sum of infinity by putting the values into the given equation. Question number 9. A curve has a second derivative as this. It has a curve, a stationary point is given. Determine whether the stationary point is a maximum minimum point. These are totally free marks, guys. You see 2 marks here. That means we have to at least give 2 steps. We get 1 mark for showing the working and 1 mark for our final answer. So what is the working? We're just going to put the value of our x, like 0.5, into our second derivative and see if it's greater than 0 or lesser than 0. If it's greater than 0, minimum function. If it's lesser than 0, maximum function, meaning maximum and minimum point. So if I put 0.5 in this equation, I get 56, which is greater than 0, hence proving that this stationary point is a minimum point. Now, find the equation of the curve. A beautiful question. Now, this is integration, 7 marks. Guys, this is totally free marks to earn for us. Now, how do we solve it? We are supposed to integrate it, meaning that we are supposed to do the opposite of differentiation. So if we used to multiply the power outside, now we're supposed to divide the power by adding something. So minus 4 plus 1 would be minus 3. And dividing the power would be minus 3, 6 divided by minus 3. Similarly, minus 3 plus 1 is equal to minus 2 divided by minus 2, and we have a constant of plus c. Well, why a plus c? Now this is a YY question. Why do we have plus C? Well, if we derivate, I have this best way. Okay. If I have an equation y is equal to 5x plus 20, and if I derivate it, I'll just get 5. And if I have an equation of y is equal to 5x plus 100, and I derivate it, I'll still get 5. And you see there's a term. There's a possibility there might be a term, or there might not be a term. And if there is a term, we can't find it, because if it's 20, I'll still get the derivative 5. If it's 100, I'll still get the derivative of 5. That means there's a constant and it's unknown for us. But when we're finding an equation, we can find this because we're given some points. The stationary point here. So we have a plus C. Dy over dx is this. So now we have to find the plus C at this point, and then we could go forward and find this, solve it further to find the equation from this derivative, first derivative now. So at the stationary point, our dy over dx should be 0, and our value of x at the stationary point is 0.5. Substituting these values, we could find that our value of the constant was plus 6. Now we could move forward and integrate it into terms of phi. Now solving it a bit further, we get y is equal to x raised to the power minus 2 and blah, 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 blah. Now we have c again. There's a constant. So we could now find it as well, because we know that y and x, our values are given in the top part and the stationary point. Substitute them and we get the value of c as 7. And that is how we find the equation of the curve. Yeah, that's it. We're done. If you don't understand integration and differentiation, let me know. I'll make a separate video for just differentiation and integration, okay? Question number 10. The diagram shows a curve. I think there's something to do with area and volume. Okay, we have an equation. Okay, we have x is greater than, okay. Point P is given. Now we're supposed to find the area between the region of A, this region. And we have the equation of the curve. This is the curve. This is the line, guys. This line, QP is a line. So we know the bounds, the upper bound and the lower bound is 7 and 0. And the area can be easily found by doing integration. Integration. 7, 0. It was 1 over 2, we plus 1 divided by 1.5. Because 1 over 2 plus 1 is 3 over 2, which is 1.5. And then we divided by the derivative of the inner term, 3. 4 as it is. Well, if we see y by doing it, now let me see something. 3x plus 4 is power 1 over 2. If this was my term, let's say my y was this, and if I was supposed to differentiate it, I would have done something like this. I would have multiplied with this derivative, and then I would do 3 over 6 plus 4 into minus 0.5, okay? Because I'm multiplying the internal derivative. That means when we're doing integration with the opposite of differentiation, we are supposed to divide it. So that's what we're doing. Solving it. There's a plus c here as well, which can be neglected and can be written, because at the end, it is just canceling out. It has no effect on our answer. So now we have 7 and 0, both values, 7 as x, then 0 as x, and then subtract them. So the area of A is 13 units square. Yes, 13 units square. Now they're asking us to find the area of region B. Well, there are two ways to find the area of the region B. One is to find the area of the triangle. No, that's the only possible way. Let me think. No, there are two ways. There is like one way to find the area of the line between 0.0 and 7 and then subtracting them from A, but that would mean the exactly same thing as finding the area of the triangle and then subtracting with the area of A. The area of the triangle, we need the base into height. But for that, we need the value of Q. And for the value of Q, we need this line's equation. And for that, we need the derivative at this point. So all the things are connected like a chain. So let's try it to find the derivative at point P first. So dy over dx. We have the equation of the curve, so derivating it and finding the dy over dx. Dy over dx found. We know the values of the points y1 and x1 as 7 and 0. Substituting them, and we get this beautiful equation. Now at point Q, which is lying on the x-axis or y-axis, our x-axis value should be null, should be 0, meaning that 0 is equal to 28/5 is my value of Q. The area of B would be 1/2 base into height, while the base is 7 and the height will be 28/5. Keeping that in mind, solving the simplification, and we get the area as 6.6 units square. That's it. Area of B is done. I think this is the last question. Question number 11. We have two functions, f and g, and for all roots of the x, they exist. F of x, they 0 exist. Find, no, we have not find, we have to show that g f of x, a composite function, is equal to 8x squared minus k minus 1. But, if I put g, f into g, there's a c. And having a c is not good because we need in terms of k. But we are given something, guys. We are given that the inverse of g is equal to c at some certain conditions, okay? So if I make a g of x is equal to 8x squared, like substituting instead of x, putting 4x squared minus c, we get an incomplete function. But now we're supposed to find the value of c. It's given that g inverse of 3k plus 1 is equal to c. If it's g inverse, I take it to the other side, it should be g. gc is equal to 3k plus 1. Well, g of x was given as 2x plus k. Now if we replace x with c, we'll get 2c plus k. So 2c plus k is equal to 3k plus 1. Simplification, c is equal to k plus 0.5. Well, I'm working in decimals because they are less confusing, and instead of fractions, they take a lot of space. Fractions take a lot of space. Now putting this value, substituting it, solving it, and we do get the composite function as 8x squared minus k minus 1. But they gave us a long place to solve it. But it's fine. Next question. The curve with the equation, this is transformed. Yes, good question. 3 marks. First of all, there's a translation, there's a stretch, and there's a reflection. We're just going to follow the steps they are given. No, right now we are not supposed to find the sequence because we're just going to follow the sequence that's given. Translation, 2 and a 3. Well, it's a positive 2, that means there's a negative 2 in our equation, and there's a 3, there's a positive 3 in the y-axis. So if this appearance dependent means the x-axis and this means the y-axis translation, if this is the x-axis, whatever sign it's given here, we write the opposite right over here. So x minus 2 is equal to plus 3. Now we're going to stretch by a factor of k in the y direction. When it's y direction, it means we are multiplying the factor with the whole equation. Multiplying with k. Now we are supposed to reflect in the x-axis. Now guys, see something. If I have a graph that is something like this, and it's supposed to reflect in the x-axis, it would be something like this. Meaning that my x values are only going to, wait a minute. My x values are going to remain the same, but my y values, guys, they are going to be from positive to negative, which means that my whole equation should change the sign. Meaning that the whole equation will be multiplied by minus 1. So the final would be minus k into this, and we are done. Translate, stretch, and reflect. Minus k, bracket, 8 into x minus 2 squared minus k plus 2. Okay, so I was saying the answer key, they did not simplify 3 minus 1, but I did it, and I don't think that's a problem. Let's move forward. So it is given that the range of h of x is lesser than or equal to 15. But our h of x function is this. So it should be lesser than or equal to 15. Let's try to solve it. If it's the range, and we're given the quadratic equation, and the constant here is actually equal to the range. It's a formula. I don't know where in our book, but it's given. This thing is called a range. But the thing is that this is -8. That means that what does it mean? It should be lesser than and equal to -15 because it's a maximum function. Whatever value I get should be lesser than or equal to 15 at this point. So k squared minus 2k should be lesser than we find the value of k, and we found the value of k -3 and plus 5. Now -3 would be ignored because it was given at the start, like 2 pages ahead. The c and k are positive constants, and we also derived an expression of c and k. C is equal to k plus 0.5. We bring the same expression back down after 2 pages. No, is it 2 pages or 1 page? After 1 page on this part C, and substitute the value of k is positive 5 because c and k are positive constants. We get the value of c and k as 5 and 5.5. So that's it for this paper. I would be attaching a link to this paper, solved paper, in my description as well, so that it can help you. Until then, bye-bye.